One good day, pre-algebra. We are kicking off our math year with CO1, identifying whole numbers, integers, and rational numbers. Is this review from last year? You see those terms, and you're sitting there thinking, cakewalk. We already know this stuff. Anybody? Or are we all going to learn something new today? You are free to speak. Very good. Okay. So we have some terms that we get to define, and that they are whole number, integer, and rational number and irrational number. Anyone want to share what is a whole number? What is a whole number? It's like our number system can kind of be divided into like different sections or groups, just like the animal kingdom, right? You've got all these different subsets of animals, but then you got different categories here. Football, you've got your conferences, then you got your divisions, right? You can separate. So a whole number is a positive non-decimal number. Okay, a positive non-decimal number. Oh. A positive non-decimal number. So examples, 1 would be a whole number. 2 is a whole number. 3 is a whole number. Should I continue? 4 is a whole number. 5 is a whole number. 6 is a whole number, right? So you got the point there. You can abbreviate whole number with W if you would like. How about integer? What is an integer? Anybody? Anybody? Okay. An integer is a positive or negative non-decimal. Okay. A positive or negative non-decimal number. So including all the whole numbers, an integer can also be negative. -1, -2, -3, -4, right? So these graphics down below here, some of the examples of whole numbers that we mentioned before, 4 is a whole number, 11 is a whole number, 20 is a whole. Those are also integers, okay? The integer box has the whole number set as a part of it. So a number that is an integer, but not a whole number would be something like -8. That's why we have to put it in the integer only box, not the whole number box. It's got that negative piece to it, okay, which makes it integer, but not whole. 4 is both whole number and an integer, okay? Give me another example of an integer. Yes? -10 would be an integer. Not whole, because it's not positive, okay, but it would go in that integer section. Give me another example of an integer. -5, perfect, okay? How about a rational number? This is a pretty big set, okay? You can see it's the largest rectangle that I have down here. Rationals, they include integers, they include wholes, so they can be positive, they can be negative, they can also be decimals or fractions, okay? Decimals, fractions. So a rational number is a positive or negative decimal, I should say in parentheses, that ends or repeats. And fractions. So a positive or negative decimal that ends or repeats, and fractions. A positive or negative decimal that ends or repeats, and fractions. So our example of wholes, 4, 11, 20, they're also rational. Because you can write 4 as a decimal, can't you? How can you write 4 as a decimal? Anyone know? The whole number 4, right, as a decimal? I heard someone say it. What? 0.04. Not 0.04. You have the right pieces, though. 4.0, right? 4.0. Okay. How would you write the number 4 as a fraction? Or any other whole number as a fraction? 1/4. Other way around. 4 over 1. Okay? Yeah, because you have 4 wholes, right? The denominator of 1 is a whole, 4 wholes. Okay? So any whole number can be written as a decimal or fraction. Any integer can be written as a decimal or fraction, which also makes them rational. But then you got a number like 3/5, right? That is a fraction. That's only going to be rational. Okay? That's only going to be rational. You've got a number like negative 5.1. That's a decimal and has to be written as a decimal. That will only be rational. Okay? Questions on that relationship? The difference between whole numbers, integers, and rationals. Because then you've got that box that's completely separate, the irrational ones. None of the numbers we have up there so far are irrational. Okay? Does anyone know what an irrational number is? An irrational number is a decimal that does not end or repeat. A decimal that does not end or repeat. What's probably the most famous decimal that you've heard of that goes on forever? 0.677. E? Yes. E is a famous irrational number, and since it's a decimal that goes on forever, we just use a letter, E. It's a lot easier. Okay. There's probably one that's even more famous than that. That one's famous in the science and the engineering world. There's another one that's kind of across all subjects famous. It has to do with food. There's even a day of the year that's named after it. Scarlett? Pi Day, right? 3.14159, blah, blah, blah. I got a poster up there. Okay. The pi, which we use a Greek letter for, okay, symbolizing that it goes on forever. If you've got a decimal that's not famous but doesn't end, doesn't repeat, we can use the ever popular, we got this decimal here, 1,209,765, no pattern, no repetition, it doesn't end. If you see a decimal that has a dot at the end of it, that means it goes on forever. Dot. There's more to it, right? Like when your parents text you and they're like, "Are you at your friend's house?" And you respond, "No, ... Like there's more to the story there, right? Tell me more. What I want to know. That's kind of the same thing there. Okay. Questions on what we have? Okay. My super cool analogy for all this stuff, I'm going to scroll down a little bit here. Another way to think about it, you are a 7th grade student, which is kind of like a whole number, right? You are a pretty specific part of your school. You are also part of the middle school, which would be integers, okay? 8th graders are also part of the middle school, but they're not part of the 7th grade. You are part of 7th grade and also part of the middle school, all right? And then SVDP, which includes a lot more grades than just 7th and 8th, a lot more than just middle school, they'd be like the rationals, right? So you're like the wholes. You can call the 8th graders integers for the rest of the day, and then walk down the hallway, say, "Hey, rational student," right? Anyone else that's part of the SVDP community. And then you've got all other schools over here because they're not part of the same school, right? They're separate, completely separate, right? That number system is kind of the same way there. Okay, practice. Mr. Happy Pencil. So this is going to be your homework where we don't finish in class here. We've got about 7 minutes or so remaining. It says classify each number as a whole number, integer, rational number, or irrational. List all applicable categories. So a number like 65, what category or categories does that fall into? Yeah, Nolan. It's a whole number. Why? Just asking. What about it makes it whole? It's positive and it's not a... All right, so that's why it's whole. It's also integer because every whole number is also an integer, okay? Because integers are positive or negative non-decimals. What else is it? If it's whole, if it's an integer, it also has to be rational, right? Rational. Anytime you put a W, you'd better be putting an I and an R because every whole number also falls into that category of integer and rational. And the reason why it can be rational is because you can write 65 as a decimal. 65.0. You can write 65 as a fraction. 65 over 1. That's why it fits there. All right? How about negative 12.7? Category or categories? Regan. Rational only. If it's a decimal, can't be whole. If it's a decimal, can't be an integer. Therefore, it's got to be rational only. Okay? Negative 1. Integer, because it's a negative non-decimal. It's not whole, because it's not positive. And because it's an integer, it is also rational. Okay? Ooh, there's a symbol we haven't talked about yet. What's that bar over the decimal mean? Regan? Right. Whatever section that little bar is over, it means that part repeats. So in reality, this decimal is 2.78787878787878787878. Okay? Mathematicians are super lazy people, I'll just be honest. And so instead of writing that out over and over and over again, we just say, well, let's just put a little bar over there. It looks kind of like a bed. And since I'm lazy, that's just going to, right? It means that this decimal goes on forever, but it repeats. And because it repeats, what does that make it? It goes on forever, but it repeats. Rational, right? If you look at the definition up at the top for rational, it says a decimal, then in parentheses, that ends or repeats. Okay? Our definition for irrational was doesn't end, doesn't repeat. So although it goes on forever, because it's got that repetition, it's going to be a rational number. Going to be a rational number. Let's skip the next one and go to 3.360928 ... What does that mean? The ... Scarlett. Irrational. It goes on forever and there is no repetition. Okay? The ... means there is no repetition. So it's important to note the difference between a decimal that doesn't end and is rational. It's got the bar over it. A decimal that doesn't end and is irrational. It's got the ... Okay? Negative 30/15. This one is kind of designed to trick you or at least make you think a little bit. What do we know about negative 30/15? What is it definitely? Since it's a fraction. Definitely rational, right? Any fraction is going to be rational. Virtually every number is going to be rational unless it's irrational, right? But what else is negative 30/15? Why is it an integer?
Because it's negative.
Not only because it's negative, but what else?
Because it's a fraction.
Well, integers, our definition says they're not fractions. So why is this an integer? What's negative 30 divided by 15? Which, remember, is really what a fraction bar is. It's just a division symbol. What's negative 30 divided by 15? Negative 2, right? So this fraction has a value of negative 2. Is negative 2 an integer? Yes, it is. Okay. So in math, we know that there are all these things. Values can be written very different ways. How many different ways can you write 1/2? Well, 1/2, 0.5, 50%, 2/4, 5/10, right? All these different ways to write a value of 1/2. Here's an example of where that integer is kind of hidden. It's a fraction, but because it works out evenly, you can actually divide negative 30 by 15 to get negative 2. It's also going to be an integer. Okay, so make sure you're checking for that. One like 2/3, we know it's rational because it's a fraction, but is 2/3 divide evenly? 2 divided by 3, does that work out evenly? No. So it's not going to be an integer. It will not be whole. Okay. The second page. So this is going to be part of your homework for tomorrow. Finishing that up. The second page says answer each question. Some questions may be not possible. What is a rational number that is not an integer? Give me an example of a rational number that is not an integer. Look up above on the front page. What was something that we only put an R for and not an I? Zoe. Negative 12.7. It's rational because it's a decimal. It's not an integer because it's a decimal, right? So that's what that section is there. Then the next one, determine whether the statement is always, sometimes, or never true. An integer is a whole number. Is an integer always a whole number, sometimes a whole number, or never a whole number? It can be. So sometimes an integer is a whole number. Okay, sometimes it is. The next part, use a calculator to evaluate each radical and classify it as rational or irrational. We're going to save that for tomorrow, as well as the brain buster at the bottom. So your homework for tomorrow, you can end at the green line. Okay? That's all the further you need to go for tomorrow. Remember, all I'm looking for is that you attempt everything. If you come in with one question blank, you will not get credit for the assignment. Adrian, you can find this lesson on my YouTube channel. Don't forget to like and subscribe. My outro, I say, that's how you math. You respond with gusto. Don't forget to like and subscribe. Ready? That's how you math. We'll try that again. That's how you math. Better. That's how you math. It's a work in progress.